So that's the basics of classes. Let's have a look at a few more things you can do with them and how they work internally. Let's say we want these two properties, and then we want a third property called number 3. Now sometimes the properties themselves that you expose aren't necessarily always going to contain just the information you want. Sometimes they might want to contain other information. The easiest way to explain that is, instead of having this calculate class, we could have this number 3 perform the calculation. So what we would need to do is we could declare internal variables. A common method for doing this would be to have an underscore. So for example, underscore number 1. This isn't any technical reason why you have to do this, it's just more a common way of doing things. And because it's internal, we don't need a getter and a setter methods, we'll just define them. So let's define 2. Oops. What we will do now is, when we define these number 1s and 2s, rather than just store them intrinsically within this property itself, what we will do, we shall redirect them to the internal property instead. So on our get method, we shall return the value of our internal number, and on our set method we shall set number 1 equal to value. Let's do the same for number 2, except it's going to return 1 and 2. Now the way we have it at the moment, there is no difference with these two numbers, what we have done there, than when we had it set like that. It's basically doing exactly the same thing, except it's storing the numbers themselves within an internal variable. And these numbers 1, 2, 3, as we mentioned earlier, because they're not set as public, we can't actually access them, only the public properties. But what we might want to do is, on number 3, we might not want a setter method at all. We might just always want to return the calculation. So in this case we return number 1 plus number 2. So this is effectively doing the same thing as the calculate method, but now instead of being a method, it's actually a property. It's just that we're, instead of just returning the value of whatever we've set it to, we can actually perform calculations. So once again, in here, let's set these numbers again, except here we're going to say and we're just going to reference the property. So now if we run that, we're getting the exact same thing. This way of having separate internal variables to store our public variables can be quite handy when we start using something called constructors. When we call our object up here, as you can see, we've not included anything in these brackets, and that's because the object itself doesn't need to take anything in. For example, our calculate method takes in 2 numbers, but our class itself, doesn't actually need to take any numbers, but sometimes you might want to. So for example, when we create our base object class, we might want to set some predefined numbers in there when we actually create the object. So what we do is we create what's called a constructor, and the way we do that is we create a public my object, so we're calling it the same as our actual class, and we're going to tell it to take in couple of numbers. And we're going to assign them. So number 1, the internal number 1 equals our number 1 that we are passing in, and same for our number 2. Actually, it's getting yes, that's correct. So if we were to run this now, you'll see that it's not working, because now the my object is expecting to take in 2 numbers. So what we now have to do is send in, and because we're putting them in there, we no longer need to manually set them there. So as you can see, it's a bit of a shorter-handed way we can construct our object and predefine base values when we create the object. And as you will see, we're getting the same result. Now sometimes you might not want to add numbers, or you might do. So what we can do is we can call what's called overloaded methods and constructors. So for example, we could have another constructor here that simply does nothing. And now when we define the object, we can simply omit those, and because there are 2 constructors of my object, one that takes 2 numbers and one that doesn't take any numbers, it just knows to use this constructor here. So for example, instead we could still perform some logic in here. We could set them to some base values of our own choosing. So now we can say my object 1, we will create it with no values. Let's create another instance of the object called my object 2, but this time we're going to pass in 10 and 10. Let's just copy this line. And then run that. So as you can see, the first object that we passed no parameters into, it's taken our default constructor, and the second object where we've used what's known the overloaded constructor, it's taken the 10 numbers in, and so use those instead. Finally, just as we had 2 different constructors, we can do the same on methods themselves. So for example, we can have public int calculate, which again returns the same value, but again, because it's not taking any parameters in, it's going to use the default values rather than the numbers we're passing in. Actually, we'll just need to use the internal numbers there. So again, on our object, oops, we can run calculate with nothing, so you can see there, or if we click the down arrow here, we can see or it wants to take number 1 and number 2. So as I say, that is known as operator overloading, and it's just very handy to do when you have the same method or the same object with multiple constructors to be handled in different ways.